Problem, evaluate the integral of 2x plus 3 divided by square root of 7 plus 6x minus x squared dx. First, we must express the quantity under the radical as by computing the square on the variable. So 7 plus 6x minus x squared is the same as 7 minus parenthesis x squared minus 6x. So we want to complete the square of x squared minus 6x, and in doing so, we obtain 16 minus x minus 3 squared. So if you complete the square on this term, here you need half of 6 squared. So add it and subtract it. So if you add it in and subtract, when you remove parentheses, half of 6 is 3 squared is 9. So you have 7 plus 9. So now next, rewrite the integral and replace what is under the radical with the expression that is equivalent expression here, and we obtain this. Now the next thing to do is to set u equals x minus 3, and then du will be dx, and solving for x so that we know what 2x plus 3 is going to be. We got 2x plus 3 equal to u plus 9. So now the integral in terms of u will be integral of 2x plus 9 divided by square root of 16 minus u squared and d times du. Now we want to split this integral into two parts, because you see that if you take the derivative of what is under the radical, you get negative 2u. So if we didn't have this part, we could have just did the change of variable u, let's say v equals 16 minus u squared, and that would be easy. So we need to break it into two pieces, and here's the other piece. Now one with numerator 2u and another with numerator 9. So now this one, we learn also how to evaluate this kind of integral by trigonometric substitution. So now this one, we just do the change of variable v equals, we set v equals is 16 minus u squared, so dv is negative 2u du. And now you do that, that means the square root of v now is v to the 1/2, right? So, and 2u du is equal to negative dv. Therefore, we have a negative v to negative 1/2, because 1 over v to the 1/2 is negative v to the negative 1/2, so dv. So integrating this means, okay, we are raise the power, use the power rule for integral, so we have v to power negative 1/2 plus 1, that means v to power 1/2 divided by 1/2. Now, dividing by 1/2 means multiplying by 2, so you have negative 2v to the 1/2 plus constant. And the next, you simplify, so v is equal to square root. V is what? 16 minus u squared, so negative 2v to the 1/2 is negative 2 square root of 16 minus u squared, and then we have that. Now we want to integrate the other one. So also here, I think there's a mistake here. We need an e there. So right. So to integrate the second part, that means this part, we need to do trigonometric substitution, and the appropriate trigonometric substitution is equal to setting u equals 4 sine theta, and du then will be 4 cosine theta d theta, and square root of 16 minus u squared will just be 4 cosine theta, and therefore the integral becomes, if you replace du with 4 cosine theta and square root of 16 minus u squared with 4 cosine theta, then we get just the integral of 1, and that means that the integral will be theta plus constant. And what is theta? We know that u is equal to 4 sine theta. That means sine theta is u over 4. That means theta is sine inverse of u over 4. And we remember what is u? U is x minus 3. So therefore, if we go back now in the original equation, replacing u with x minus 3, we get the first part now will give us negative 2 square root of 16 minus u squared is just square root of 7 plus 6x minus x squared. And then we said here we have sine inverse of u over 4. So replace u with x minus 3 over 4. X minus 3 get this, and that's the answer. Now let me add this here, and we are done for solving this problem.